right. Hi, folks. How are you? Bueno. All right. So you should have 4 pickups. You should have an answer packet to even answers for this semester now. Are you good there? Okay. You should have notes. Unfortunately, the back did not get copied, so I'm going to have to go on to the back of that. Also, feel free to scratch out that bottom note over for test material review. That actually is on this page here. Your test is tomorrow. It's through last week's material, which is review 13. And yeah, the topic list is not exhaustive, but it's the stuff that I am starting from when I make my test. The sample problems are optional. You don't have to do the review. It will not be collected. It's whatever will help you prepare. I will post a key to that review on my website before I leave today, so you can see if you did things well. Feel free to come in 7 to talk about for practice stuff or before school if you have questions. Okay. Okay. I'll assume you're saying okay. Your problem set. That problem set 72 is due Friday. It's due Friday, not tomorrow. Are we clear on the whole logistics thing? Yes. I am usually here by 6:30 or so, but I don't really want to see anybody at 6:30. So, how about? No offense. Maybe 7-ish is fine. 7 is fine. Okay. Good question. I will be happy. By the way, besides that video, if you feel like you need more practice on anything, I will be happy to do so. Also, if you'd like any of your reviews back, I get kind of backed up on grading over the week and I get tough in the week. That's just how I used to. So, if you'd like one of your reviews back that you feel like it would help you study, then come by after class or after school and I will mark it down and give it back to you. Okay? Here we go. The lesson is pretty straightforward. It should take about 20 minutes. There's really just 3 new derivatives. You have tons of technique, and you know how to take most derivatives, but there's 3 little holes in your derivative technique toolkit that you need to fill. First is derivative of exponential. I hesitate to even teach you this because I feel like you can just figure it out on your own without instruction. So that's what you're going to do. Go. Take the derivative of 2 to the x. Feel free to talk it over. I'm sure that you might have seen this at the end of the year, but I don't want you to go by memory, nor do I want you to look it up. I want you to think it through. Talk it over, help each other, and we'll go over it in a couple of minutes. Yeah. But like,
I don't know the second one. This problem.
Come up with that basic one in your because of that, the entire back is just cracked. And he suggested you do it, but if you understand it, then I'm just not going to check it. I did the first one. But the ones on the back are like what are they called? James, what's the word for like different? Like what different languages? Very not help. Like different like yeah. No, but like what's the word for that? No, like it's like the 4 basic Oh my god, I can't remember. I don't know how to do like another way.
Give me Elway. Do you have Elway? Where does that come from?
I just learned that. And he said I can't look it up, so I can't look it up. So that's why.
What do you?
Yeah, let them.
Better, or how is it like something? Example X is the
That's what I did for your best. Can't you do it with
Yeah, but he's not
Okay,
talking about.
we're getting there. Looks like people are getting the right idea.
No, he's saying.
Yeah, I just realized that. I was like, wait, why is it
No, that's.
Okay, so give me one idea. Yes,
Take the natural log side.
take the natural log of both sides. Now, I gotta say, this is a super skill because that is also how you're going to do what's called logarithmic differentiation. Instead of this, imagine if you were given that. X to the x, which is one of the most powerful functions there is. A growing number to a growing exponent. What would you do? Well, the general school of thought is x in the exponent is bad. And to solve that problem, you take the natural log to get it out of the exponent. That's just a general problem-solving technique. X in the exponent is bad. Use a log to get it out of the exponent. Then, that allows you to use exponent rules, which is this. Now, what? Now take the derivative with respect to x on both sides. What is the derivative of the left side? 1 over y. Y dx equals natural log of 2. And so dy dx is y natural log of 2 in x terms, then that would be 2 to the x natural log of 2. From that, I could say that generally, if you take the derivative of a to the x, its derivative is a to the x natural log of 2. Now, here's where I pause and go off on my pet peeve tangent. Consider this. Read this for me. Because. Not BC?
No.
I agree, not BC. When you read this, what do you read?
Without.
Without. I agree, without. Not WO. Read this.
One.
Not one, not LN. Natural log. Why do you say this is without, but do you say, you read the letters here, L, no LN. Natural log. Natural log. Okay, LN. Yeah, LN. Oh my goodness. Yeah, that's right below. That's right below students who say like every other word.
Oh my god, I can't believe that.
What's number 1?
That's actually number 1. Students that say like everything. Number 72 is daughters that leave shoes all over the house in the dark when I am getting up in the middle of the night. Yes. Oh, yes, thank you. Sorry, it's not always a to the x natural log of 2, it's a to the x natural log of a. Thank you, you're my bad. That would be really weird for it to always be x log of 2. The second way, I've had only a few students see it this way. It's always crazy to me. Teaching this class is kind of cool because there are people that are weirdly brilliant and think of things that I would never have even thought about. So I had this kid that said, oh, I could call 2 e to the natural log of 2. Now, do you agree that is true?
Yeah.
Okay. I said, all right, the reason I would do that is because I know how to take the derivative of e, which makes sense. If they took the derivative, it is the derivative, like it previously was, times the derivative of the inside via chain rule, and that's natural log of 2, and then they said, okay, and then I just replaced back e to the natural log of 2 with 2 to the x. Oh, I just lost it perfect. Does that mathematically sound? Sorry, Al. Okay, does that make sense? Now I'm really blurry. All right, I'm going to go pirate on you for the rest of the period. All right. I am going to go put it back in. Try this one now. This one is also. The reason I just had a breakfast burrito, so my hands are spicy.
Don't put it in.
Yeah, I made that mistake once. That'll never happen again. So I will let you do the next one, and I will be back in a second.
Just pop it out on your glasses. They're 2 inches to push up. No, you're right, James. You're brilliant.
In my head, I say.
James, the one way to 2. Incredible. You don't understand. So, oh wait, so now you take the log of this, and it's just basically the same steps as before. This is what we're doing. Only way to do everything. To the y to the...
From last night.
I'm pretty sure
Oh, you mean exponential.
Yeah,
I
exponential.
thought you were saying multiply by 2.
No, well, I may have said that.
Yeah, I know. I was like,
or natural law.
yeah, or 7. I think I did. I think I did this.
I didn't say
I can't say 1 over 2. But it's 2.
Yeah, and then you substitute y or the equation back in for y.
What do you say? What do you say?
1 over x and 1 over x.
1 over x, ln. Did you say ln? You didn't say ln. Okay, let's find a way to get started.
Exponentially.
Exponentiate. I love the vocabulary. That's awesome. 2 to the y equals x. Then what? Hi. Thank you. Then take the natural log of both sides, allowing you to bring down.
I got right there.
Okay, now, if you remember the change of base formula, that's really what you just did, is use the change of base formula. You changed from log base 2 to natural log. So then, dy dx or y prime is just 1 over x natural log of 2. So the derivative of log base a is 1 over x natural log of a, not natural log of 2. All right. Just to make you think a little more, show analytically and graphically why log base 1/2 of x must be negative. Think logically, prove, justify. Sure you can. Create a logical argument that no one can find a hole in.
Mr. Rickman, is
Wait.
my book check out?
Oh, right.
Negative, right?
Yeah.
Very good.
L is never a number less than 1 is a long. Yeah, because it goes like... Wait, no. Yeah. Oh yeah, it's negative y. It's still impossible.
Oh, yeah.
So it has to split out. Well, because of its domain, it has a negative three. Why not? I don't know. Because it's slope. The slope of this must be negative. Unless I'm doing the wrong graph. Which is impossible.
Oh, is it well not?
This way. Log it goes like this. The log goes like this.
Yeah, but you have to take into account.
One half. So the log graph was those graphs.
Yeah.
Okay, so what's the analytical justification why this must be negative? Talk to me of something you did. That's graphically, so analytically.
Take the derivative.
Take the derivative. This must be 1 over
X.
Okay. Justify to me why that must be negative.
Because log of 1/2 is negative. And
Okay, natural log of 1/2 is negative. That can be an accepted math
X
fact.
must be positive.
X must be positive because it's the domain of a log. And so from that we can conclude that 1 over the product of those two must be negative. Okay? That's a foolproof argument. I agree with your reason. The graphical would be to look at the graph of log base half of x. How is that different than the normal, what I would consider normal, log graph? As, talk some limits to it. As x goes to infinity, he started you off, finish it out. As x goes to infinity, y goes to negative infinity. When the log base is less than 1, it looks like that, right? Right?
Yes.
Right. Okay, and surely if I drew tangent slopes, which is the derivative, they are all negative. Okay? Turn it over, please. This is the part of the lesson that I neglected to get copied to the back. There's a third derivative idea, and that is, call it the derivative of absolute value. If you are going to sum this up, the strategy of this in one word, you would say, pi.
You wrote pi?
What would pi have to I agree, I say pi to start with. But if you're going to talk about the derivative of absolute value, you'd say pi. Okay. So say f of x is the absolute value of x squared minus 4. In order to communicate this well and the reasoning well, it would be nice to have a graph. What does the graph look like today? So parabola to start with, before the absolute value takes effect, wanting to go down to negative 4, but then the absolute value takes effect, and what happens? It looks like a W. It causes a reflection of the part below the x-axis into the positive. And so it does indeed look like a W, yes? All right. You can take the derivative of this, but you can't take the derivative with the absolute value in there. So you really need to translate this into a piecewise equivalent. Change f to an equivalent piecewise function. I could write any absolute value function as a piecewise function. So let's call f of x the piecewise. I'd prefer you go left to right. So the far left branch. What is it? Not where is it? Just what's the function?
X squared minus 4.
It's x squared minus 4. Wouldn't you agree that that absolute value had no effect over there because that was positive anyway? And so that's for x's where?
Less than negative 2.
Less than negative 2. Okay. The inside, is that normal x squared minus 4?
Minus x squared.
Yeah, it's actually the opposite of x squared minus 4. What normally would have been x squared minus 4 is now minus x squared, or the opposite.
Between negative 2 and 2 inclusive.
Negative 2 and 2 inclusive. You're including the middle branch. Could I include it on the outside edge?
Yes.
I could. Okay, so that's doesn't have to be one or the other, as long as it's included somewhere. And then the far right branch?
X squared minus 4.
X greater than 2. All right. With that, then, the derivative is pretty straightforward. If I wanted to write an equation for the slopes over here, what are the slopes of the derivative over there? 2x. For x is less than negative 2. What about for the inside?
Negative 2x.
Negative 2x's. For
Negative 2 to 2, not inclusive,
why not inclusive?
because the derivative doesn't exist.
Okay.
Why not inclusive?
Sharp turn here. So do not include on the derivative. Okay? It's not differentiable at those points. It's abrupt change in slope. All right, what about the far right side? 2x for x is greater than 2. Try 1 on your own. F of x is, oops, the absolute value of x minus 1 cubed. Find f prime. X minus 1, that's not what I intended, sorry. X minus 1 cubed.
I could do that. Wait, what would it be if you cubed?
That's a good question. So it would be like normal x minus 1, which, oh, that's actually fun.
You should graph it.
Oh, we should do that. I will make that a question on the homework test.
Oh, no.
One.
I was saying like
You
right
can
now.
think your way
for-
through all the types of things.
Oh my God. Shut up.
You destroyed us all.
Oh, no.
So for greater than 1, it would be nothing. It's just x.
That's all we got.
Yeah. Sort of, yeah. I would say so.
So you're looking at
Oh, yeah.
Oh, waiting for the
Oh, yeah, I guess it is.
it would be the same anyway. That's a fun question.
Is it a saddle? Is it like is the slope 0 at 0? Well,
I don't think so.
Jesus?
I think it was a saddle point.
Oh,
yeah, it is a saddle point. It's the slope is 0 at 0.
Shout out to Miss Kenny.
Classic. Classic singing.
Okay, so let's see if you got this right. What is the function in piecewise? Minus. You could just say the opposite. That's fine. You don't have to distribute and all that mumbo jumbo. X minus 1 cubed would normally be negative, but we're negating that, taking the opposite. That's for x's. Less than 1, okay? And for x minus 1 cubed, 4x's. Greater than, what about equal to? Needs to be defined somewhere. All right, so here's the derivative then. The derivative of the left branch, what is it? Negative 3, x minus 1, quantity squared, x less than 1. For the right-hand branch, 3, x minus 1, squared, x greater than
What?
and equal to 1.
Wait, so can you switch it so that the first one was?
Yes. Okay, now why is this one okay at the flex point?
It's no sharp.
There's not a sharp turn because originally the graph had a horizontal tangent there. There was a horizontal tangent there, and when you flip that, that's not an abrupt turn. It is differentiable at 1. Okay, so it should be included in this case. That's partially why your graph, see if there's a horizontal tangent at that flex point, if the derivative is 0 at the meeting point, it could be, and often is, differentiable. Okay? Are you with me? Okay. So that is that. Questions on review 13. I don't remember where this class is at. Review 13, do you still have review 13 or did you already turn it in? It's White Fish today. And it's titled Review 13, I think. That's the one I think I titled correctly.
Yeah.
All right. Can you tell from your ink where we are? I know it's been a couple days.
You got
D, I think.
most likely.
Okay, so is it alright if you set like if you had a third function, so you just put 0 as x is
0 at x. Yes, that's fine. Yes, absolutely. That'd be simple. You're right. Yep. If f prime equals 0 at the meeting point, it could be differentiable there. Sorry about that. Okay, that's a good point. I like that. All right. So this thing, did we get to the water in, water out, or is that where we are? We're in that one.
Yeah, we're on
D. Okay. And I don't know about this one, but later on I had some errors. You might be tweaked out by the last one. I think I had some funny business going on. So we'll get there. But if you recall in C, we had that the function for the amount at any given time, they called F, I don't know why F, but it's the starting amount plus the amount in, which is either 8 or I, minus the amount out, which is either L or 1/2 T, not T cubed, or to the 2/3, because you're going to let T represent the ending point of the time frame. That's going to go up there, so that means you need a dummy variable here. I called it X, you could call it U, V, whatever you want, all right? The T must be here, it cannot be the other way around. So that after you integrate, T is what's left. Are we cool on C then? All right. At what time is the amount of water in the tank at a maximum? Do you read that as a relative extreme of problem or an absolute extreme? Absolute. All right. So absolute max by EBT must be at endpoints or critical numbers, or critical points, however you want to rephrase those. They're both fine. The endpoints are most certainly, I'm going to go to the bottom of this so I have room here. The endpoints are, I think with this class changed it to 0 to 90, or did I? 0 to 90. Okay, so that's cool. I can find the amounts there. The critical points, now there are a couple ways to write, hey, these are where my critical points are coming from, but you do have to make sure you explain where your critical points are coming from. So what's one way of saying, here's where I do to find the critical points? Critical points are where? The first derivative. The first derivative for the amount. Do we have a function for amount? Yeah, we just wrote that. So you might have said where f prime equals 0 where undefined, but that said, it's not clear by any stretch. It's not like I could ask the guy in the street, say, hey, what's f prime? And it's a no-brainer. You need to say, hey, I know what f prime is. F prime is, what's the derivative of that? This is the fundamental theorem of calculus part 2 when you take the derivative of an antiderivative. So what's the derivative of 50? 0. And now I'm going to take the derivative of the antiderivative, which is just function. 8 minus, it would be t in there after you put t in, took the derivative, it would be a function of t to the 2/3, yeah? I believe the only solution to that was 64, if I'm not mistaken. All right. So proceeding from there, we need to find the amount, which again was called f at 0, which is 50, f at 90, which I might have had an error here too. What was your amount at 90 if you did that well? Say again? Anybody? I don't have my key in front of me. I can't. Yeah. So what is the integral, 50 plus integral from 0 to 90 of 8 minus 1/2 x to the 2/3 dx? And it's actually, don't worry about it, it doesn't matter, because if you recall, the graphs look like this, and the in rate was greater than the leave rate up to here, so it was actually it does matter, doesn't it? Oh no, it was increasing up to 64, and then after that the leave rate was greater, so it started to decrease. So it was increasing up to that point. That's going to be my max at 64. So if you don't have, that doesn't matter. That's not going to be my max. The true max is f at 64. What did you get for f at 64?
It says what time, so I just have to.
Oh, okay. You still need to find it to justify your answer. So find the amount. What was it? 224? 54. 254-ish. All right. So that was greater than the other two candidates, and so we would conclude the absolute max is at 200. Is at times 64 seconds, minutes, hours, minutes. Okay. Yes.
Online, I checked last night and it said 514.
That's an it.
Oh.
Oh, maybe it's not an error. I thought it was an error. For which one? 64 or for 90?
I think it you got it in fraction form.
Because then I did.
And cut it off.
Oh, that's what I did this without a calculator, and yeah. So I think that the bottom of the paper didn't scan. I can't find my keys right now, so I don't know if I can. So yeah, it should be 200-ish.
Okay.
Sorry about that. Which would make sense. 514 or something. 508-ish. I don't know. Are we good?
Yeah.
Sorry, I'm frustrated I don't have my key in front of me, but it'll work out. Don't need that page. Oh, we didn't do that last. What'd you get for the pumped in, pumped out problem? C? B? B. Yes? Okay. I'm fine if you call this something like R, and then you just write integral from 0 to 6 of R rather than rewrite it. But you're just slapping your calculator at that fundamental stuff. Are we cool? Okay, this guy is where I had a few mistakes. Actually, Barty was just a few. The rest were probably fine, I think. So let's start with A. Over what intervals of G is G increasing? What's the connection? Given that you don't really have a flat out here is G, you have an F, what do you do? Yeah, the big idea of calculus is G is increasing where? Yeah, G is increasing where G prime is positive. And what is G prime's connection to F? Now, if I took the derivative of this to be the derivative of that, the derivative of the antiderivative is just a function, okay? G is increasing where G prime equals F is positive. This is on, or at, whatever you prefer. Where is F prime, or F positive? Negative 4 to 2, and negative 2 to 2, not inclusive. You could have switched the two pieces. And that's fine. Yes? You should not. You should not. Okay, that's a good point. I leave the arguments naked. You can, but if you call it if you use arguments, g is a function of x, and that really should be equivalent to f of x. But I don't even include the argument.
Why do we have to write -42 and -2?
So there's no question.
Is f actually positive at that point?
No.
No, 0.
What do you mean negative?
Oh, I see what you're saying. Yeah, I don't know. Yeah, -4 to -2, and -2 to 2. It's a rough day. I'm sorry. I'm worthless today. Apologize. Okay, sorry. I apologize. Now I understand. G has a relative extrema. Now this isn't saying specifically minimum max, just any kind of extrema. So an extrema happens by first derivative test, where the first derivative changes sign in some fashion, right? So that's really all you have to establish is that G prime, which equals F, changes sign at -4 and 2. So you have relative extrema there. And again, you could put your answer first, x equals -4 and 2, because G prime, which equals F, changes sign there. You could switch the pieces of the argument. It probably flows better that way. Are you with me?
Yeah.
Did I make a mistake? -2 is not an extrema. Why not?
Doesn't change signs.
Doesn't change sign. You can think of it as saying increasing and stays increasing, flattens out, then stays increasing. So it's not an extrema. Okay? So please don't think, which is probably the most common error, is people would say it's where f has a 0, and that's not true. Okay? F equals 0 is not an extrema. It's where f changes sign. Yes?
So is -4 still an extrema because g of x is 0? So is it only after 0 or is it still?
Here?
Yeah.
It is an extrema because f is going, g prime, which is f, is going negative to positive. So that's a min of g. Yeah, it's definitely an extrema. Yep. Yes?
Why isn't the 5 -1?
Good call. So what about the endpoints? Didn't even think about it. Good call. I gotta say, that's a great idea. At the college level, they often do include the endpoints in the analysis. The AP, for whatever reason, kind of shies away from that. They don't want to get into endpoint extrema. But in order to talk about this well, let's talk about that. Those would be relative extrema because G is increasing or decreasing up to that point. And so you're right, those would be relative extrema. Yes?
Another question, should -4 not be better because G is only defined from 0 to x?
That's what Anomica was saying.
Maybe I don't understand. Say it again.
So since G of x equals the integral from 0 to x, it's only defined in those bounds, so even -4 not be.
X, so G is defined for all real numbers, and you can put -4. It is okay to go backwards it's thinking of, if you think of G as area accumulation, going backwards then you're really saying you're losing area. And so G is decreasing as you go this way because you're losing accumulated area. And it is okay to go below 0. It is. Yes.
Then you have to do a negative integral.
Right. Yeah, and we'll tackle that in D, or E rather. Concave up. G is concave up. How do you get into concavity? Okay, so by definition, something is concave up if the second derivative is positive. Start with the big idea of calculus. G is concave up if the second derivative of G, which is f prime, which is slope of f, is positive. Okay? Well, that's one way to talk about the slope of f. And this is on -5 to -3. And -2 to 0. Any others?
No.
That's it. Okay. You could also, it's possible to also say G prime, which equals F prime, is positive on this interval because F is increasing there. You could also say, instead of the slope, you could say increasing F implies F prime positive. Okay? G has an inflection point. Did you say where G double is 0? Hope not.
No.
Okay, it's where G double changes sign. Furthermore, I don't want you to say G prime is 0 and changes sign because it's unnecessary. You're making it sound like that is a necessary condition. It's not. It's just changes sign. So don't include what's not necessary. You're making it a harder bar to jump over any other time. It's just about G double. Okay, G has an inflection point. Where is G double changing sign? Okay, x equal -3. You say -2, 0, because G double, which equals f prime, which equals slope of f, changes sign there. You could also say at those points, because G double, which equals f, changes sign because f goes from increasing to decreasing or vice versa. Okay? Last but not least, this is where so if you're fully awake and you're a critical thinker, you read that and think, yeah, Rickman, you're an idiot. If you are not a critical thinker, then you're more like, oh, whatever, okay, I'll go with it. So in that case, then, really, in terms of history, if you thought, I'm an idiot, then you would have been great in Nazi Germany, because you would have been the person that's questioning things, thinking, this is stupid, why are we doing this? But if you said, okie dokie, then you would have been one of those people who said, oh, everybody else is doing it, let's go. Okay? Think for yourself. Think critically. Don't be a little Nazi. Think very hard. Okay? So, think for yourself. Why is that so stupid? G is 0 is 4. Here's G. G is the area accumulated from 0 up to whatever point. So how much is accumulated from 0 to 0? 0. And yet I have that it's 4. How can that be? I don't see that. That's stupid. That cannot work. You cannot accumulate 0 to 0 and get area. That's a no. Okay? So, think critically and say, Rickman, you're an idiot. Sometimes. What is the absolute max of G then? Forget that part. It wouldn't even be necessary to do the problem. You can do the problem without that. I'm not sure why. I don't know what I was thinking. Okay, so let's go here. Absolute max by EBT means absolute extrema must be at endpoints or critical numbers. Okay, I feel like that's important. I require you to start an absolute extrema problem with that thesis, I suppose you could say. The endpoints are x equal -5 and 5. The critical points are where, now you're looking for the extrema of G, so you need to know where G prime, which is f, is 0 or undefined, and that's at -4, -2, and 2. Okay? Now, I intentionally did this maybe a different way than you might have done it so we can get a discussion going on here. According to that, then, I have 5 candidates for the absolute extrema, right? Okay. Let's find the endpoints, and then I'm going to talk over here in a second. So if I find G at -5, that if I plug in, that goes there. I don't really care, and you and I might do this slightly different, but we should still get the same answer. I don't like it when my integrals go backwards, so I would change this to the opposite of what you get going that way, yeah? If I then say, all right, the integral for that is the area, signed area. Now the signed area for that is these two triangles cancel each other out, and I'm left with a positive triangle and a positive quarter circle, yeah? So I said then, positive triangle, positive quarter circle, and I got for that result -1 times 2 over 2 plus 2 square root, so pi, I guess, sorry. So something like pi negative pi minus 1. Suppose something like negative 4.2. You follow? Do we agree on that? Okay. G at phi is forward, so it's not problematic. That has a quarter circle. And you could, I suppose, you either go triangle, rectangle, or trapezoid. Did you go triangle, rectangle, or trapezoid? Triangle, rectangle. Those are below the axis, so they're negative area. And again, I got something like pi minus 1/2 minus 1. So pi minus 3/2. That's probably more like, 1.57. Cool? So far, so good? All right, now here's where you have options. You have 3 candidates, and one option is just you find G at all those candidates and you just do it, okay? If the figure has some pretty ugly geometry, you might consider narrowing some of the candidates out. I can dump negative 4. Why? Yeah, the curve G prime, so F goes negative to positive there. That's a relative minimum. That's not a good candidate for an absolute maximum. And so if you want to dump that as a candidate, you can, but you have to say why. You can't just say, forget it, I'm not doing it, and keep it in your head while you're not doing it. You can say G prime equals F goes negative to positive at negative 4, so min, not max. How could you dump, by that same kind of reasoning or similar reasoning, how could you dump another candidate? And which one? Negative 2. G prime equals F. What is the reasoning? Doesn't change sign. At x equal negative 2, so not a max. Okay? So the only candidate I really have to investigate is G at 2. The area accumulated from G0 to 2 under the curve is the quarter circle. That's 1/4 of pi times 2 squared. That's pi. And so from that I conclude do they want what the absolute max or where the absolute max? The absolute max value is pi. If you wanted to say because it's the greatest of the candidates, fine. If you want to say because it's greater than pi minus 3/2, which is definitely greater than negative 1 plus pi. It's the greatest of the candidates, is fine too. Okay? Does that make sense? Is that? Oh, no. Okay. How about this bad boy? Did you get this one?
No,
I was hamstrung with this because I didn't have my calculator with me, so I had to do a lot of thinking. That's cool. Thinking is good. How do you get started? Make the connection to calculus. What? F is increasing where? F prime is positive. You need F prime. What is F prime? What's the derivative of the antiderivative? The function cosine of x or t now? X squared plus 2. In order to then see where this is increasing or positive, I need to start by saying where this is 0 to find where it stops being positive or starts being positive. Wouldn't you agree that cosine is 0 at pi over 2, 3 pi over 2, 5 pi over 2, and so on, yeah? So x squared is pi over 2 minus 2, or pi over 2, 3 pi over 2 minus 2, or 5 pi over 2 minus 2, and so on. So x is the positive root, because we're talking positives. Positive square root of pi over 2 minus 2. I think that's the square root of the negative, so that's not a solution. Positive square root of 3 pi minus 2 rooted. Positive 5 pi over 2 minus 2 rooted. So I'm not sure exactly where I'm at here. This is probably about, what, 7.5 minus 2. That's at the square root of 5. That's still in there. That's still less than pi. So I think if you did a sign test, you get something like one of those. answers?
One.
The C? Okay, C. And then this one, I had an error. I had x plus 2, which doesn't actually make a region.
Yeah.
My intention was negative x plus 2. You don't have to do it, but if you can use the practice, then you should do it as practice. I'll take this either today or tomorrow if you want to keep it to look over. Today or tomorrow. Don't forget to
Mr. For number 4, since you're allowed to use our calculator, you have to show all of the...
No, I just didn't have a calculator. So yeah, you didn't have to show. I actually wanted to see.
Just
I needed to see the derivative.
okay.
Yeah.